Everyone, myself Jansi Reddy S from the Department of Computer Science and Engineering, USN 1VE 20CS055. Currently studying in a semester of 6 in the section of Aryabhatta. Now we are going to discuss about the topic of detailed explanation of pixels and screens and how pixels is represented on screens related to the subject computer graphics and visualization. Now let us discuss about the introduction part. Computer graphics deals with generating images with the aid of computers. Today, computer graphics is a core technology in digital photography, film, video games, cell phones and computer displays and many specialized applications. Computer graphics is concerned with all aspects of producing pictures or images using a computer. The field began humbly 50 years ago. This field has started 50 years ago itself with the display of a few lines on a cathode ray tube which is called as CRT. Now we can generate images by computer that are indistinguishable from photographs of real objects. We continually train pilots with simulated airplanes, generating graphical displays of a virtual environment in real time. Feature length move made entirely by computer have been successful both critically and financially. Now we'll discuss about the basics of computer. Computer graphics is an art of drawing pictures, lines, charts and etc. Using computers with the help of programming, a computer graphic image is made up of number of pixels. What is pixel? Pixel is the smallest addressable graphical unit represented on the computer screen. The next concept is application of computer graphics. The development of computer graphics has been driven both by the need of the user community and by advances in hardware and software. The applications of computer graphics are many and varied. We can, however, divide them into four major areas. Those four major areas are display of information, design, simulation and animation, and the last one is user interface. Now let us go through how the pixel and the frame buffers is framed. Virtually all modern graphics systems are raster based. The image we see on the output device is an array, the raster of picture elements or pixels produced by the graphical system. Figure 1.2, which means the cat figure which is available over here, you can see the eyes. It consists of some small particles. All by combining all those small particles forms the pixels. Image of 80, the cat. First one, the first figure represents the pixels. Detail the area around one eye showing individual pixels. Look at that second picture which you'll get to know about the detailed information about the pixels. Here each pixel corresponds to a location or small area in the image. Collectively the pixels are stored in a part of memory called the frame buffer. Here we'll get to know about the relationship between about the pixel as well as the frame buffer. The frame buffer can be viewed as the core element of the graphical system. Core is nothing but the outer coverage area. The resolution, the number of pixels in the frame buffer determines the detail that you can see in the image. The depth of precision of the frame buffer defined as the number of bits that are used for each pixels determines properties such as how many colors can be represented on a given system, which means that the higher the pixel quality, the higher the image quality will be there. Like in mobiles we'll be seeing as 50 megapixel, blah, some other megapixels. As the pixels increases, the image quality also increases. For example, a 1-bit deep frame buffer allows only two colors, whereas an 8-bit deep frame 8 buffer allows 2 into 256 colors. In full color system, there are 24 or more bits per pixel. Such systems can display sufficient colors to represent most images realistically. They are also called true color system or RGC color system because individual groups of bits in each pixel are assigned to each of the three primary colored red, green and blue used in most of the displays. These are the three major colors which is used in most of the displays, and these are the main colors. High dynamic range, which is known as HDR systems, use 12 or more bits for each color component. Until recently, frame buffer stored colors in integer formats. Recent frame buffer use floating point and thus support HDR color easily. Now let us discuss about the deep concept of pixel. In the pixel, a word invented from picture element. The pixel is a word which is invented from a picture element in the basic unit of programmable color on a computer display or in a computer image. Think of it as a logical rather than a physical unit. Pixels are the smallest unit in the digital display. Up to million of pixels make up an image or video on a device's screen. Each pixel compresses a subpixels that emits a red, green and blue, which is known as RGB color. These are the main colors. Out of these colors we'll frame out the remaining other colors which displays at different intensities. The RGC color components make up the gamut of different colors that appears on the display or computer monitor. When referencing the resolution of a display, numbers like 1920 into 1080 refer to the number of pixels. Let us know how do pixels work and how are they used. The number of pixels determines the resolution of a computer monitor or TV screens, and generally the more pixels, the clearer and sharper the image. The resolution of the newest 8K full ultra high definition TVs on the market is approximately 33 million pixels or 7680 into 4320. The number of pixels is calculated by multiplying the horizontal and vertical pixel measurement. Those I have mentioned above as 7680 into 4320 is the horizontal and vertical measurements of the pixels. For example, HD has 1920 horizontal pixels and 1080 vertical pixels, which totals 2,73,600. It's normally shown as 1920 into 1080 or just as 1080p. The P stands for progressive scan. A 4K video resolution, for example, has 4 times more pixels than full high definition, which means HD image, what we call as HD is full high definition, and 8K has 16 times more pixels than 1080p. Other common display resolutions include the following: 480p, which is standard definition is 640 into 480. We can also call it as 480p and is often used for small mobile devices. Look at this picture. Here you'll get to know how the pixels will look like. This image will be consisting of 720p, which is in HD quality, is 1280 into 720. As I have mentioned before, we can also call it as 720p. 1440p, which is of 2550 into 1440 and considered quad HD, is often used for PC gaming monitors, and 4K videos resolution, which is Ultra HD, is 3840 and into 2160 pixels. The specific color information that a pixel describes is some blend of three components of the color spectrum, which is the RGB. Up to 3 bytes of data are allocated to specify a pixel color, 1 byte for each major color component. A true color of 24-bit color system uses all 3 bytes. However, many colors display systems use only 1 byte, which limits the display to 256 different colors. A bitmap is a file that indicates a color for each pixel along the horizontal axis or row, called the x-coordinate, and a color of each pixel along the vertical axis called the coordinate. A GIF file, for example, containing a bitmap of an image along with each other data. Pixels also either back it by an additional panel or an individually lit. An LCD TV screen illuminates all pixels using an LED backlight. If the display is mostly black on an LCD screen but only a single pixel needs to be lit, the whole back panel still must be lit. This leads to the light leakage. Pixels are also either backlit by an additional panel or individually lit. An LCD TV screen illuminates all pixels using an LED backlight. If the display is mostly black on the LCD screen but only a single pixel needs to be lit, the whole back panel still must be lit. This leads to light leakage in the display. This is more noticeable during the credits of the movie, for example, where there is a slight glow around the white letters against the black background. OLED display by constant don't need a backlight as each individual pixel illuminates itself. This means when one pixel needs to be lit, no light is leaked to the surrounding pixels. In the movie credits example, this means an OLED display won't have the same light glow around each of the credits as it would in an LCD screen. OLEDs typically have better contrast, black levels and viewing angles than LCD screen. This says that LED is always better than LCD, but also suffer from burn-in. OLED screen can also be folded or bent, which is an feature in many modern smartphones. Thank you everyone for watching for my video.